All right, so today we are going to do the differential equations FRQ. All right, so in the past we could pretty much always count on there being a slope field, but I'm not sure about the hybrid testing because when there was a slope field in the past, in your test booklet, you would see the slope field or you would see the dots, and that's not going to happen. Like your packet, what you write in is going to look just like what I've been giving you. So I'm not sure about the slope field, but maybe we're going to practice like what we would do if there was a slope field on there. All right, there probably will be a tangent line approximation. And so that you're going to do y equals y1 plus m times x minus x1, where m is going to, use the differential equation to find the slope. Right. And then you will solve a differential equation with an initial condition. And so kind of like a mnemonic device to help you remember how to do that is SISIS, where you start off and separate. That's the first S. So just separating the variables will get you 1 point on this FRQ. All right, and then do you guys know what the I would stand for? Integrate or integral. All right. That might be the most difficult point to get because sometimes there's like weird things with the functions. And then you are going to solve for C. And that involves plugging in the initial condition. All right, so a lot of times when I look at how they graded this, you'll get a point just for considering the initial condition. So even if you plug it in wrong or do something wrong, you get a point just for considering it. Sometimes you get a point for writing plus C. All right, and then you're going to isolate y. And again, we can leave that super messy. It's fine, but you do need to get y by itself. And then sometimes, and unfortunately the ones I picked for you, you didn't have to do this, but sometimes you may have to select to go with the initial condition. So for example, you would maybe have a plus or minus square root. You would have to choose which one it is based on your initial condition. You can't have both for your final answer. Okay, so when we did differential equations, this might have been the best test you guys did. So I think that there were so many people who made 100 on it. Let me find this. Uh-oh. Sorry. Apparently I didn't download this. This is great. This is on video. You guys can see what I do every day. Okay, so here we go. This is our differential equation. And this one does have a slope field. Like I said, I'm not sure what they're going to do about that. Another thing is this one only has ABC, and your all right, and so these test booklets already have A, B, C, D, and so all of your free response questions will have A, B, C, D. So from what I understand, there's not going to be a blank one. So it'll be a little weird today because I'm using one from before, but that's okay. All right, so this is the differential equation, and we have a slope field for this differential equation. And we're going to sketch the solution to the curve that passes through the point 0, 2, and sketch the solution through the curve that passes through the point 1, 0. So I think they might still do this, but what you would have to do is kind of draw it yourself. Now they're not going to want you to draw all the little slopes. What they would want you to do is put a point at 0, 2, and put a point at 1, 0. And then looking at your slope field, I'll let you guys do that. All right, so looking at your slope field, the 1 through 0, 2, what kind of line is that going to be? Straight. Yeah, it's just going to be a horizontal line. So through that one, it'll just be a horizontal line. All right, and then the other one, you can it's going to go through here, so you can kind of get what the what the shape is going to look like and just try to do it. I honestly don't think they're going to do this, but for many, many years, that's what it looks like. That's what they were asking for. Now, the one you guys are going to do to practice is one where you draw the slope field. And so it's way easier to do it that way, where you just put the points and then draw your little slope. So I think it's unlikely you'll have to do one like this. That's okay. All right, and then part B. We're going to let y equals f of x be a particular solution to the given differential equation with initial condition that f of 1 is 0. Write an equation for the tangent line to the graph of y equals f of x at x equals 1, and use your equation to approximate f of 0.7. So what do we need for a tangent line? There's two things, the pot and the side. And you can do that, it's fine. As long as you're showing your work within each one, it's fine. They might not know what you're talking about, but it's okay. You show your work that you do know. Are you given the pot? Yeah, this is the pot, the 0.10. And then what are we going to do to find the slope of the tangent line? We have the derivative. The differential equation is the derivative. So we just have to plug it into the derivative. So we're going to do dy over dx, and we're going to plug in the 0.10. Now I want you to show everything plugging that in. All right, and then after that, we're just going to get 4/3. All right. And then our tangent line is going to be y equals, and then it's going to be the y part of your pot plus your slope times x minus the x part of your pot. So that's the first thing they asked you to do, was to find the tangent line, write an equation for the tangent line. The second thing they asked you to do is to use it to approximate f of 0.7. Now we can drop off that 0, it's fine. We're going to plug in 0.7 in for x, and then are we going to do anything else? No, we're going to stop. That's it. We're going to leave it like that. We don't have time to be messing with this.
Will we get a point off if we put an equal sign rather than
I don't think so. I don't think they're picky about that, but I honestly don't know. Yeah, try to. If it's asking approximation, that you do approximately. Okay, and then part C is the big part. So this will be like 4 or 5 points to solve this differential equation. So we're going to find the particular solution of y equals f of x to the given differential equation with the initial condition at f of 1 is 0. All right, so here we go. The first thing we do is separate the variables. So we're going to get the y's on one side and the x's on the other side. And that will get you a point. If you don't separate the variables, you get no points for this at all. Then you're going to integrate. Well, actually, I'm going to rewrite the one on the left. So if you have something in the denominator and it has a power that's not 1, you're probably going to want to rewrite it with a negative power, unless your brain works better than mine, which is quite possible. Now, if it had just been a y minus 2 in the denominator, we'll just do ln when we integrate. But in this case, that's going to be wrong. Okay, so now we're going to integrate. We're going to add 1 to the power and divide by the new power. Same thing on the other side. And you are going to remember to do plus c on the right side. Okay. I'm going to clean it up just a little bit, but typically as soon as you get c, it's a good idea to find it. Now that was a little super messy, so I'm going to just make it prettier and easier to plug in the initial condition. All right, so our initial condition was the point 1, 0. So I'm going to put 1 in for x, then I'm going to put 0 in for y. Okay, so you can make C 2/6 if you want to. You can make C 1/3. Either way, it doesn't matter. I'm probably going to change it to 1/3, but you don't have to reduce it. And so what we'll do is we'll take that and we'll put it here. So the very last thing you wrote before you put in 1 and 0, that's where you're going to put the C. I'm going to run out of room. That's okay. There's not a part D. I'm just going to keep on writing. All right, so I want this y to be in the numerator, so it is perfectly fine if we just flip this one over and flip this one over by putting it over 1. Now that's not pretty, but it's fine. This does not have to be pretty. All right, then I'm going to multiply by that -1, which is just going to make the numerator up here -1. And then the last thing we're going to do is just add that 2. And then if you wanted to call it f of x, you can, but it's fine if we just call it y. All right. What questions do you guys have about differential equations? Okay.